Welcome to Physics with Joe. Today we're going to be looking at the difference between scalars and vectors, how you represent vectors visually, and how to add vectors together graphically using what's called the tail-to-tip method, also known as the tip-to-tail method. So let's jump right into it. Let's start with a basic question. What is physics? Physics is a study of the fundamental laws of nature. These are the laws that govern all physical phenomena in our universe. From subatomic particles to clusters of galaxies, physics is really a study of the rules of the universe in which we live. And how do we discover these rules or laws of physics? Through many years of experiments. And anytime you're doing an experiment, what you're really doing is measuring different physical quantities. For example, I might measure the mass of an object, its density, what is its temperature, how fast is it moving, is it accelerating, how much energy does the object have, what is the object's momentum. All of these different physical quantities are generally classified into one of two types, either scalars or vectors. And the difference between scalars and vectors in one word is direction. A scalar is any physical quantity that only has a magnitude, which is a number plus units. Some examples of scalars that you'll see in physics: distance, speed, time, mass, energy, work, density, temperature. These are all quantities that can be completely described by giving the amount in terms of a number plus units. So for example, speed, the magnitude would be how many meters per second, how many miles per hour, how many kilometers per hour the object was moving. So 10 meters per second, the magnitude is 10 meters per second. On the other hand, a vector is any physical quantity that has both a magnitude and a direction. And a direction is the key component to a vector. You cannot describe a vector without giving the direction. Some examples of vectors you'll see in physics: displacement, velocity, acceleration, force, momentum. In order to completely describe a vector, you have to give the amount in terms of the magnitude, but you also need to give a direction. So if I said a force was 6 newtons, that is not enough information. I need to know the direction of the force. Is it 6 newtons at a 20-degree angle? Is it 6 newtons to the east? You need to specify both the magnitude and the direction anytime a physical quantity is a vector. The way we represent vectors visually is by drawing an arrow. The length of the arrow represents the magnitude of the vector, and the direction the arrow is pointing represents the direction of the vector. So if I had two vectors and one was twice the magnitude of the other, so let's say a 10 Newton force versus a 5 Newton force, I would draw the 10 Newton force, I would draw that arrow twice as long as the arrow representing the 5 Newton force. One of the things that can make vectors a little challenging is that they cannot be added together like normal numbers or like scalars. For example, if I had a mass of 10 kilograms and I added a 5 kilogram mass to it, the total mass is going to be 15 kilograms. I can simply add those two numbers together. However, if I'm talking about vectors, that is not the case. So if I told you I had a 10 Newton force acting on an object and another 5 Newton force acting on it, and I wanted to know what is the total force, I do not have enough information unless I know the direction that each force is acting. What we're going to look at is how do I add vectors together graphically using something called the tail-to-tip method. Now in a future video, I'll talk about adding vectors analytically using trigonometry, but today we're just looking at how do I add vectors graphically. Before I go into adding vectors using the tail-to-tip method, let me just say I would not use this technique if I needed a numerical result. So if I needed to know the magnitude and direction of the sum of two vectors, I would get that by using components in trigonometry like I'll cover in a future video. However, adding vectors graphically is a very powerful way of double-checking your work when you're adding them using components. I like having my students draw a quick sketch just to double-check their work. So the tail-to-tip method, very simple, 3 steps. Step 1, draw one of the vectors to scale and in the correct direction. Remember, the arrow points in the direction that the vector is, and the magnitude of the vector is proportional to the length of the arrow. So I would choose an appropriate scale to make drawing the vector easy. So for example, let's say I had a 100 Newton force vector. I would choose a scale like maybe 1 inch equals 25 newtons, and then I would draw that force vector 4 inches long. Step 2, draw the second vector, again to scale and in the correct direction, starting from the tip of the first vector. And then the resultant, the sum of those two vectors, starts at the tail of the first vector and ends at the tip of the second vector. So again, 3 easy steps. Draw the first vector to scale and in the correct direction. Draw the second vector starting at the tip of the first one. And again, this can apply to 3, 4, 5, however many vectors you want. If I had 3 vectors, I would draw the third vector starting from the tip of the second one. The sum of the vectors always starts at the tail of the first vector and ends at the tip of the last vector. Let's take a look at some examples. So remember, we use arrows to represent vectors. The length of the arrow is proportional to the magnitude of the vector, and the direction the arrow is pointing is in the same direction that the vector points. So let's grab a vector or two and look at adding them graphically. So one, let's assume these are force vectors. So this A force vector has a magnitude, you can see up here, of 10 newtons. It has an angle of 53.1 degrees. And this also shows the x and y components that we're not going to concern ourselves with right now. One, let me emphasize that it does not matter where you draw the arrow. Oftentimes you'll see vectors drawn connected to the origin, but all that really matters is how long the arrow is and in what direction it's pointing. So this A force vector is the same whether it's connected to the origin, whether I draw it in the first quadrant, whether I draw it in the fourth quadrant, it does not matter. Okay, so let's choose a second force vector, B, and let's make this have a magnitude of 21 newtons at a 0 degree angle. And I want to know, what is the sum of these two vectors? Remember, the tail to tip method, very easy. Start with one of the vectors, draw it to scale and in the correct direction. Here it's already done for us. You then draw the second vector starting at the tip of the first one. And then the sum always starts at the tail of the first vector, ends at the tip of the second vector. So our sum, you can see, starts at the tail of the first vector, ends at the tip of the second vector. And it does not matter what order you add the vectors in. So let's say instead I started with vector B, and then I add vector A by drawing it connected to the the tip of vector B, and then the sum always starts at the tail of the first vector, ends at the tip of the second vector. Let's do one more. This time we will add 3 vectors together. So I got force vector A, force vector B, force vector C. So let's make B a little bit longer that way, and let's make A, we'll do it like that. Before I show you what the sum is, pause the video, try this yourself, and see if you get the correct answer. Remember, it doesn't matter what order you start in terms of adding the vectors. Let's start with B. I'm going to draw C connected to the tip of vector B. I'm going to draw A connected to the tip of vector C, and then my sum always starts at the tail of the first vector and ends at the tip of the last one. And again, just to show you one more time, it does not matter what order you add the vectors in. So let's say at first I started with A, and then added C, and then I add vector B, and again, the sum always starts at the tail of the first vector and ends at the tip of the second vector. And that's really all there is to it. Let's do a little recap of what we learned. We started off looking at the difference between scalars and vectors. A scalar is just a physical quantity like mass or length or time that only requires a magnitude to describe it, just the number plus units. On the other hand, a vector is a physical quantity that requires both a magnitude and a direction. Things like force, momentum, acceleration need both a magnitude and a direction to completely describe them. Then we looked at how do you represent vectors visually. We always represent them with arrows. The length of the arrow is proportional to the magnitude of the vector, and the arrow points in the same direction that the vector is pointing. And last but not least, we looked at adding vectors graphically using the tail to tip method. Simple process. First, you draw one of the vectors to scale and in the correct direction. Then you draw the second vector starting at the tip of the first. The sum of the two vectors, the resultant, starts at the tail of the first vector, ends at the tip of the last one. That's all there is.